Good afternoon, students. Welcome back once again to the mathematics class. In the last class, we have seen the introduction part of statistics, that is mean, median, and mode. Now, let's see the measures of dispersion. Now, today's concept is what? Measures of dispersion, right? So, there are four measures of dispersion. Let's see. Already we have discussed in the yesterday's class by taking an example for mean marks by taking a three students in three subjects they scored the marks, that is physics, chemistry and mathematics. We have taken respectively the marks, and we have seen there also a student has failed in a chemistry. Therefore, in order to make the better interpretation of data, average alone are not enough. So in that reason, the variation of marks from the average marks for students A and B comparing to the variation marks of a average marks for a student C is what? Dispersion. Variation is a property of what? It is a deviation of values from the averages. So we are about to going to study measures of dispersion. For that reason, we have come across measure of dispersion. So again, there are four measures of dispersion. There are four measures of dispersion which are in common use, which are in common use which are in common use. They are, first one is what here? First one is range, second one is quartile deviation, third one is mean deviation, and fourth one is standard deviation. These are the four measures of dispersion. First one is range, second one is quartile deviation, third one is mean deviation, fourth one is what? Our standard deviation. So let's see the first one, what is range. Range, which is nothing but here, range is the difference, range is the difference between the highest and lowest value. The highest and lowest values in the data. Difference between what? Highest and lowest value in the data. Let's see, for example, for the data of marks, for the data of marks by data of marks obtained by three students in physics, chemistry and mathematics. Physics, chemistry, mathematics, that is that is physics, chemistry, mathematics, that is in physics, the student in three students in three subjects, that is PCM. Student A, he got 59, 60, 61. Student B, he got 55, 58, 67. Student C, he got 72, 17, 85, right? So let's see, the ranges are given by ranges are let's see the ranges here. See, range of marks of a student A, range of marks of student A, which is equals to the difference between, actually the range is the difference between highest and the lowest value in the data. So the highest value in A is what? 61 minus 59, which is equals to 2, right? Next, second one, the range of marks of a student B, range of marks of student B, which is equals to 67 minus 55, which is 12. And third one is range of marks of student C, which is equals to 85 minus 17, which is equals to what? 68. So let's see here. What we can conclude from this example. Yes, we can conclude from this example that the range is based only on extreme values. It shows too much fluctuations, right? The range is based on what? Extreme values, and it shows too much fluctuation. It is very much influenced by any abnormal extreme value, we can say. But still, the range is used in statistic quality control of goods because an industry may be interested in narrowing down the difference of the extreme performance of a product, right? For industry, still the range is using for the reason for a statistical quality control of good, statistical quality control of goods, because an industry may be interested in narrowing down the difference of an extreme performance of the product, right? So next, second one is quartile deviation. Second one is quartile deviation. So let's see the quartile deviation, where QD is a quartile deviation, is the interquartile range, as we have not studied QD is the interquartile range. As we have not studied quartile in earlier classes, we don't discuss this measure of dispersion. So simply you can remember this much, it is enough, right? So quartile is an interquartile range, we can say it is interquartile range. It is QD. Interquartile range. So next one is, third one is what here? Third one is the mean deviation. Mean deviation. The mean deviation is the set of values. Let's see what is mean deviation. Mean deviation. Mean deviation of a set of values of a variable from an average is the arithmetic mean of absolute deviation. Absolute deviation of the values of variable from that average. There are three mean deviation, namely there are three mean deviation, namely MD, it is mean deviation from arithmetic mean. X bar MD, it is from median M and MD from mode Z. MD form of the arithmetic mean, X bar MD from median M and MD from mode Z, right? So let's see different formula for this. Mean deviation X bar, which is equals to 1 by n summation X minus X bar, or mean, which is equals to 1 by n summation mod X minus m, or MD in terms of Z 1 by n summation X minus Z. However, MD of Z is not commonly used, right? This is definition taken as formula to find MD for ungrouped data. Grouped and ungrouped data is there already. So here we have to find the ungrouped data. Ungrouped data. So which is nothing but what? Our mean data for mean deviation. So let's see an example for this one. For example, find mean deviation about the mean for the data 38, 70, 48, 40, 42, 55, 63, 46, 54, 44, right? So here we have to find the mean deviation about the mean for the data has been given. So let's see solution. First let us take x, and the value of x is 38, 70, 48, 40, 42, 55, 63, 46, 54, 44. So now x minus x bar, mean deviation, that is nothing but mod x minus x bar, it is right, x minus of x bar. So x minus of x bar is nothing but what? Let's see, n equals to here the number of values, n equals to 10. So summation x equals to what we get here, 500. If you add all these, then you will get the sum of value is x is 500. So x bar, which is equals to summation of x upon n. Summation of x is 500 upon n means it is 10. So 50 is our x bar. So summation of mod x minus x bar, which is equals to what we get, the value of x is here, summation of mod x is, which is totally what we get, it is 84. Summation of mod x minus of x bar. So finally what we get, the mean deviation x minus x bar, the value is what here, x bar is 50, x minus x bar, that is x value, we have x bar value that is 50, right? 50, 38 minus 50 is 12. Similarly it is 20, 2, 10, 8, 5, 13, 4, 4, 6. So finally mean deviation of x bar, which is equals to what we get, 1 upon 10 into 84, which is equals to 8.4, is the required value, right? So with this we will conclude our today's lecture. In the next lecture we will see some more examples on mean deviation and mean deviation for grouped data also. It is for ungrouped data, the example what we have discussed now. So next we will see the mean deviation for grouped data. So till then, take care, stay at home, stay safe. Thank you.